Section 11.5 is some techniques for finding derivatives, and there's quite a bit of algebra we need to be able to accomplish this. So we're going to do some review of rational exponents and exponent rules, and a little bit of review of polynomial functions and their behavior. So first we're going to go through the exponent rules, and one at a time, the product rule, and then we'll do the quotient rule. So the product rule says if my bases match, I add my exponents. So if I don't remember these rules, I write them out with small numbers and say, well, let's see, the meaning of x cubed is x times x times x. The meaning of x squared is x times x, so I can see that I must need to add the exponents because I have 5 x's. So I'm really encouraged, rather than memorizing rules, to understand the meaning of the rule. So then we have the quotient rule that says if my bases match and they're in a quotient, that I subtract the lower exponent from the upper exponent. So again, if you have x to the 6th over x to the 4th, think about the meaning. This says you have 6 copies of x in your numerator and 4 copies of x in your denominator. X over x, no matter what x is, that equals 1. This x over x equals 1. This x over x equals 1. And multiplying by 1, it's called the multiplicative identity. Multiplying by 1 doesn't change anything. So we do what we say, cancel, but keep in mind that what you're really doing is saying this is 1, and multiplying by 1 doesn't change anything. So we're just kind of clearing that clutter out of the way. That's not changing anything. And I have x squared left, so I can remember how the rule works by trying it with small numbers. Okay, then we have the 0 exponent. So recall that for any real number, if you take it to the power of 0, that's going to be 1, and it makes all the exponent rules work properly. So if I have 2 to the 0, that's 1. If I have 5 to the 0, that's 1. But then if I have the number -3 to the 0, you need to see what's different here. If I put parentheses around the number -3, then the -3 is acting like the b, the base. And that's going to be 1, because any real number taken to the 0 power is 1. But then if I write with no parentheses, exponents cannot operate on anything except what they're touching the corner of. So with no parentheses, the 0 exponent does not have any effect on the negative sign. So this is going to be -1. So make sure you're clear on the difference between those two. Okay, so then let's talk about negative exponents. And b to the -n can be rewritten as 1 over b to the n. And your instructions are always going to say, write your answer with no negative exponents. And then we also have that 1 over b to the -n equals b to the positive n. So my friend who teaches high school says, jump the line and change the sign of the exponent. That's the only thing that changes. See how the b does not change. Only the exponent's sign changes. So let's do a couple of examples. If I have -2 to the -3, that's going to be 1 over, the b is -2, but now the power is +3. So the number -2 doesn't change. The only thing that changes is the sign on the exponent. And then what if I have 1 over -3 to the -4? That's going to be -3 to the +4. So the -3, the b part, does not change. Only the sign on the exponent. So make sure you're super clear on that. That's going to come up a lot. Okay, so then let's talk about power to power. And these two are often confused, so make sure you're super clear on power to power. If I have b to the m to the n, this is when the exponents multiply. And again, though, if you're not sure, do this with small numbers. If I have x to the 4th cubed, think about the meaning of cubed says multiply that by itself 3 times. Well, now I see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 copies of x, so I can see how the rule works. So make sure you're really comfortable with this rule. And then we have products to powers and quotients to powers. So products to powers says if I have a product of two things in parentheses with the exponent, then the exponent acts on each one. So the parentheses give the exponent superpowers so that it can operate on all of the things inside the parentheses. So this also applies to if you have numbers. So if you have 2x to the 5th cubed, think about the meaning of cubed. It's 2x to the 5th times 2x to the 5th times 2x to the 5th. So hopefully you're seeing why they came up with these rules is it saves a lot of writing. If you see how the rule works, you can say, oh, well, I see now that that's 2 cubed times x to the 5th cubed. Okay, then the quotients to powers says if I have a over b to the n, and how I say this property to myself is the order of quotient and exponent doesn't matter. On the left, you have the quotient first and then the exponent. And on the right, you have the exponents first and then the quotient. So this property works both ways, as does the products to powers. So make sure you're clear that all those equal signs mean all of these properties work both directions. They're two-way properties. Okay, so that's section 1.2. So if you need any review on exponents, make sure and go to 1.2, and remember you have the answers to all the odd problems, and it would be well worth your time to spend half an hour reviewing exponent rules and practicing and becoming super proficient at them again. So then we have roots and radicals, and this is in section 1.5. Again, another section you should really practice on and make sure you're really fluent with these. So I'm going to erase a little space here so we can do the roots and radicals. Okay, so first let's talk about the nth root of a to the n. And we're not going to worry real hard about this, but it turns out that if it's an even root, that technically this is the absolute value of a. This is not really going to come up for us a lot, but it is a fine point that the authors want to make sure and not neglect. So if you have the 5th root of a to the 5th, though, that's just what you'd think. That's a. So that's the doing function is the exponent, then the undoing is the root, and you're back to the a that you started with. So now let's look at these product and quotient properties, and really these are parallel to the exponent properties because radicals can be thought of and written with exponents. So let's first look at the product rule. If you have the nth root of a times the nth root of b, that's going to give you the same result as the nth root of ab. So what this rule says to me is the order of radical and multiplication doesn't matter. Because on the left, I'm doing the root first and then the multiplication. You don't see any symbol, so multiplication is implied. And then on the right, we do the multiplication first and then the root. So that's what this property says to me, that the order of multiplying or applying the square root or cube root the order doesn't matter. And we have a parallel property for the quotient. If I do the roots first and then the quotient, I'm going to get the same result as if I do the quotient root first and then the roots. Okay, then let's remember how we can go back and forth between roots and radicals. So we're going to look at this property that says the nth root of a is a to the 1 over n. So notice that the n, the index of the root, it's what kind of root are you taking, and it's where you would expect to find roots in the fraction. It's in the bottom. So if I have the cube root of x, that can be written as x to the 1/3. So when I'm doing algebra, I like radicals better. But when I'm doing calculus, I can't do calculus on radicals. I have to change them into fraction exponents. Okay, so that's the basic ones. Just a quick reminder too that when we write this symbol, we all know it means the square root. There's a little invisible 2 here that the mathematicians stopped writing a long time ago because this was the most common type of root. And so they just said, we're all just going to understand there's a 2 there when you don't write a number, but know that the square root can be written as to the 1/2 power. Okay, then let's talk about this last property. This is the one you're going to need to use a lot. So let me make a little more space. Okay, so this property says a to the m over n can be written either as the nth root of a to the power of m, or you can do a to the power of n and then the nth root of that. So what this says to me is the order of taking the root or taking to the power, it doesn't matter which order you do those in. So if we think about what this would look like written in fraction exponents, I think it becomes even clearer of why you can do this in either order. Because this is the powers to powers rule that says you multiply the exponents, and either way, when you multiply, you're going to get m over n. So this and the negative exponent rule get used together a lot for us. So you're going to want to practice as much as you need to. And that's where I'm going to pause after I mention there is something I'm calling a vocabulary hunt in the Canvas files. It's just kind of a fun little activity that won't take more than 5 minutes. And it's a review of all the terminology you need for talking about polynomials. So when I say coefficient, you'll know what I mean. And when I say leading term, you'll know what I mean. So it doesn't take very long, but it's optional. But I do expect you to know the vocabulary of polynomials. So I'm going to pause here and come back and start on power functions.